A single AI agent can book a flight, but can it plan an entire trip, research destinations, compare prices, check your calendar, book flights and hotels, then send the itinerary to your team? That requires multiple agents working together. One researches, one plans, one executes, one verifies. This is agentic orchestration, the coordination layer that turns individual AI agents into a system that completes complex, multi-step goals. It's the hottest trend in AI right now, with 9,000% search growth in 2026. And in this video, I'll explain exactly how it works. Let's start with why a single agent isn't enough. A single agent has one model, one prompt, one set of tools. It works great for simple tasks: answer a question, write some code, query a database. But real-world workflows are complex. They require different expertise at different stages. A coding agent shouldn't also be doing code review. A research agent shouldn't also be executing API calls. When you force one agent to do everything, it loses focus, makes mistakes, and hits context window limits. The solution: specialize agents and orchestrate them. Here's the core concept. Agentic orchestration is a coordination layer that sits above individual agents. It decides which agent runs when, passes information between agents, manages shared state, enforces guardrails, and handles failures. Think of it like a conductor in an orchestra. Each musician plays their instrument, but the conductor ensures they play together in harmony, at the right tempo, in the right order. Without orchestration, you just have noise. Let me explain the 4 main orchestration patterns. The first is sequential, also called a pipeline or chain. Agent A finishes, then Agent B starts with A's output, then Agent C starts with B's output. Simple, predictable, easy to debug. Example: a content pipeline where a researcher agent gathers information, a writer agent drafts the article, and an editor agent polishes it. Each agent sees only the output of the previous one. The second pattern is parallel, also called fan-out. Multiple agents run simultaneously on different aspects of the same task. An orchestrator sends the task to all of them, waits for all results, then merges them. Example: analyzing a code base where one agent checks security, another checks performance, another checks style, all at the same time. Results are combined into one report. This is much faster than running them sequentially. The third pattern is the router. A single decision-making agent or classifier looks at the incoming task and routes it to the most appropriate specialized agent. It's like a receptionist directing you to the right department. Example: a customer support system where the router classifies the intent, billing question goes to the billing agent, technical issue goes to the troubleshooting agent, feature request goes to the product agent. Each specialist handles only what it's good at. The fourth and most powerful pattern is the supervisor, also called hierarchical orchestration. A supervisor agent manages a team of worker agents. It breaks down the goal into subtasks, assigns them to workers, reviews their output, provides feedback, and iterates until the goal is met. The supervisor has the big picture. Workers are focused specialists. Example: a software development supervisor that assigns a coding task to a developer agent, sends the output to a reviewer agent, gets feedback, sends it back to the developer for fixes, and only approves when quality standards are met. This is the pattern behind most production multi-agent systems. Now let's talk about the key components that make orchestration work. First, shared state. Agents need to read and write to a common memory: the current plan, intermediate results, conversation history. Without shared state, agents can't build on each other's work. Second, tool access. Each agent has its own set of tools. One can search the web, another can execute code, another can query databases. The orchestrator ensures each agent only accesses the tools it needs. Third, guardrails. You need boundaries, budget limits, time limits, scope constraints, human-in-the-loop approval gates. Without guardrails, agents can spiral into infinite loops or take unintended actions. Fourth, error recovery. When an agent fails, and they will, the orchestrator decides whether to retry, fall back to a different agent, or escalate to a human. What about the frameworks that implement this? The ecosystem has exploded in 2026. LangGraph from LangChain models orchestration as a graph. Nodes are agents, edges are transitions, state flows through the graph. CrewAI focuses on role-based agent teams. You define agents with roles, goals, and backstories, then let them collaborate. AutoGen from Microsoft uses a conversation-based approach where agents talk to each other. OpenAI's Agent SDK provides a lower-level primitive with handoffs between agents. And if you've watched my MCP video, you know that MCP provides the tool layer underneath. Orchestration sits above MCP, deciding which tools each agent uses and when. Let me give you a real-world example. Imagine building an automated code review system. The supervisor receives a pull request. It routes the diff to 3 parallel agents: a security reviewer, a performance reviewer, and a style reviewer. Each analyzes the code independently with their specialized knowledge. Results flow back to the supervisor. The supervisor synthesizes the 3 reviews into one coherent report, resolves any conflicts between reviewers, and decides whether to approve, request changes, or flag for human review. If changes are requested, it can even route to a fixer agent that suggests concrete code improvements. This is sequential plus parallel plus supervisor, patterns composed together. When should you use multi-agent orchestration versus a single agent? Use a single agent for focused, well-defined tasks where one prompt and one toolset is enough. Use orchestration when the task requires different expertise at different stages. You need parallel processing for speed. The workflow has conditional branching. You want separation of concerns for reliability, or the task is too complex for one context window. The rule of thumb: if you're writing a system prompt that's 3 pages long trying to make one agent do everything, it's time to split into multiple agents with an orchestrator. To summarize, agentic orchestration is the coordination layer that makes multi-agent systems work. 4 core patterns: sequential for pipelines, parallel for speed, router for classification, supervisor for complex goals. Key components are shared state, scope tool access, guardrails, and error recovery. Frameworks like LangGraph, CrewAI, and AutoGen implement these patterns. And the principle is simple: specialize your agents, then orchestrate them. 1 agent per job, 1 orchestrator to rule them all. This is how AI moves from answering questions to actually getting complex work done.